What does an AI engineer actually do all day? If you ask social media, I sit in a dark room hacking the matrix. In reality, I'm mostly arguing with messy data files and reading academic papers that make my head hurt. I've built systems for self-driving cars and stock market prediction. And today, I'm going to break down exactly what the job entails, the tech, the team, the salary, and the stuff that makes me want to pull my hair out. Let's get started. What is an AI engineer exactly? Basically, it boils down to data in and the decisions put on the output, right? So what happens inside the neural network or the prediction model is kind of a black box. And yes, there's active research of trying to figure out what's actually going inside there, what's happening inside there, and try to explain it. Because right now, yes, we can make a model architecture and we can put weights on it, but we need to understand what is actually happening. That's why there's active research on it. So a human analogy of this, if we're trying to make let's say, a decision of, okay, what kind of car I should buy? So the inputs, you could give it like the model, the years, what's available at the dealership, and the model it will make the comparison between the two, and then it'll give you a recommendation based off of some things in the input, like what's your budget? Are you doing a luxury car? Is it for the family? Things like that. So when you're deciding that for yourself, pretty much the black box is making that comparison, and based off the input and what your desired output is going to make a decision for you. So that's kind of like what's happening. Now, the core function of an AI engineer right now is basically it evaluates a massive data, because it's pretty much, imagine if you have to do the car analogy of comparing a lot of times with a lot of data. So this is what pretty much an AI engineer is basically scale that up to massive data to make predictions or decisions based off of certain inputs, right? Now, the thing is, it's, again, AI itself is kind of like a loose term. There's no like formal definition. It kind of like changes around. And one thing about it is, if you say AI right now, you could kind of like, it's artificial intelligence, and it's kind of loosely like replicating what humans would do. So if you're making a decision based off like how a human would do it, you could call it AI, right? Now, this day and age, it's kind of, because it's so nebulous, there's different ways you could call AI. There's even different domains of it. And I would say right now, the four that I see, you might see different names and they all cross, because you kind of have to know each one of them to actually work. But the worlds, I would say, there's machine learning engineers, data scientists, AI researchers, and applied engineers, right? So basically, a machine learning engineers, they actually design new models with that, right? So new models, new algorithms that haven't been seen before to handle problems that haven't been solved before, or improve on ones that at a more efficient way. Data scientists pretty much deals with large data, take that, processes it, scrub it, clean it, and then put a model, interpret it, evaluate what's in there, and then at the end, interpret it what the data is. So you explain to a stakeholder what it means and recommendations. And AI researcher is basically like, they are doing more blue sky, I would say blue sky ideas, that things that haven't even existed yet, and try to figure out, hey, can we do a new version? All they do pretty much is research new ideas and papers and ideas of how to design certain things. And then applied AI engineers actually taking models that exist, taking data that exists, and doing what I'm mentioning up here as an AI engineer is take data in, make a decision at the end. Usually this is what businesses are looking for to bring the business value is, this is our input, this is the decision we need to make, or to make a good prediction or a good output. Have an AI engineer build that pipeline out for it. Now, for the data scientist, one thing I want to point out, there's an actual methodology you generally follow that is called, it's pronounced like awesome, like awesome sauce. I wouldn't recommend saying that phrase, but you might understand it better there. And the reason why I'm saying that, because again, typical of an engineer, if you look at that does not really look like the word awesome, but that's how it's supposed to be pronounced. And it's an acronym that's supposed to mean O is obtain, S is scrub, explore, model, and interpret. So this is pretty much the methodology you would use as a data scientist in general. You would follow this. You would collect the data or curate the data like based off of the information you're working with. So you collect raw data, and raw is a very important thing, because this is the part people skip. People think you just take any type of data and it just works. No, you actually have to clean it next. That's what scrubbing is. You have to clean the data and fix it, because what happens in the real world You have mislabeled data. You have data that's missing. You have data that's not consistent. Or what I mean by not consistent, I use the example dates all the time, like the month and day, because like it's not consistent. There's no conformed way of how you actually do the date during the year, or anywhere regionally. We could have day, month, year. You could have month, day, year. You might have it in numbers. You might have 4 digits for the year. So you have to conform that to make sure. If you just put the data in as raw like that, you're gonna get messed up results. Then once you have it, you want to explore to see you could find any noticeable patterns. Maybe you put a heuristic, meaning like certain rules beforehand, things like that. Or the certain pattern might give you some indication of what kind of model or what kind of solution you could actually get. And then you actually use a model. Now the thing is, as a data scientist, when you say model for this, you might basically take a neural network, build it out, and build a model. So it might be unique, but you're not necessarily inventing a new algorithm that to solve this. You might be applying a model that already exists. And I'll tell you the truth, even when I explain how you should learn data science and machine learning to prepare yourself for the fundamentals, with the fundamentals to be an AI engineer, is a lot of the classic models that you learn in statistics and just classic AI. I mean classic AI before using neural networks. AI existed beforehand. A lot of those models work most of the time. One of the most famous one is linear regression, where you have a whole bunch of data and you try to put a line that best fits with the least amount of error of it. In fact, that's what you want to do. And in fact, during a data scientist, linear regression might give a good result as a model, so that might be the model. It might not, so you might have to use something more complicated. You might use scikit-learn, where you could do some simple machine learning models that doesn't necessarily do deep learning, but that could be done. And then after that, once you have obtained the data, clean it, explore what kind of patterns, and you have a model that gives some certain results, you have to interpret it. Why? Because you have to explain the results to stakeholders. Mainly, if you're working in a business, you're probably going to be asked by the executives or the stakeholders who asked for you to do this model in the first place, because they want a result for something. So they don't really care about the inner workings. They just want to tell you, after your analysis, and this is the data, what does this mean for us? And so you can interpret the data. What does it actually mean to me in layman's terms, in a way that I can understand, so I can make an informed decision of should we continue or not, right? Think of it as if you're going to your mechanic. You go to your mechanic, you ask him what's wrong. You're not a mechanic yourself. You might not even know anything about cars. They explain it to you, probably went over your head, and then after you ask, okay, so what should I do, right? And they'll tell you, based off this information, this is what I recommend, and then you decide for that. That's basically what you do as a data scientist over here. Now, the other thing I want to point out, because the main separation is for the applied part, which is what an AI engineer do, is basically applied versus research. Is that research like invents algorithms? They're looking for the new blue sky things, and very important because they're solving problems or creating a new world that we haven't seen yet. But applied actually solves problems now, and that's what businesses hire, because this is our current business problem. We want to reduce our margins or answer customer service faster. How could you use your AI solutions to make that happen, right? So my actual day-to-day as an AI engineer is that I actually do read research papers and the math behind it to see what's coming out, what's new, what's possible in the future, and to see if this can I actually apply it for my own business needs, or for my own, I say business needs, but basically my own solutions that I need to show a prototype, or this is enough information that we can build data and build it out. And then after I build a data pipelines, and then again, get the data that is relevant to what the model will actually use, so we could actually clean it and apply it. And in terms of nowadays, this is more 10 years ago, this is what I would say that was needed, because now 10 years later, there's a lot of models and apps that already exist. So the thing is, when you're working in the real world, is that don't reinvent the wheel. If something already works, use it, right? So if I look first, okay, is there already an existing solution? Do apps or APIs already exist? If it does, let's plug it in and use it for the business. Now, granted, the main thing you have to look into there is the cost. What is the life of it? Where does the data live? Is it in the cloud? Is it on-prem or premise where you can actually control it? You have to get legal involved to see what does it entail. Because even if you have certain data, those agreements change over time. So this is more of a logistical nightmare. So I have a solution, and to tell you the truth, usually this takes weeks to go through, but so does this. So that's usually my day-to-day is like, okay, this is the solution they want. This is the options I have. I can either build it myself, collect the data, make it a big science project, or, oh, I found some solution. We have to pay for it. Can we legally use it? And then let's talk to execs. Let's go back and forth, wait for legal, and then sitting until I get responses. In the meantime, building out the case and doing some tests to see how well it would actually work. Just to basically break it down into simplest terms, what is the core AI workflow high level? Pretty much in a business setting, they say, hey, this is the problem we're trying to solve, right? Okay, what is the data that we have available? What is the data that we actually need? Based off of that, and again, if I look at papers that exist that models that data, that's something similar to give a certain, they give that actually could solve the problem that they have. That's very similar, or look for already solutions that already exist out there, and then I apply a model to it, right? And then once you have a model and it's giving good solutions, at least acceptable predictions or recommendations of what the output would be, or acceptable outputs, then you deploy it and actually use it. That's pretty much a real life AI workflow high level bit. Now the thing is, this is very important. Before you start, you have to have the problem basically sorted out and agreed upon by the company or the business or whoever your stakeholder is, so you know what success looks like for the solution. So you really have to have the problem definition first, and I'll give you why that's important, because that defines the direction you go with in terms of how you model it and what you do with the data. Going back to what I was mentioning with the awesome framework, where you have the data by itself without like scrubbing it and like modeling it and like interpreting it for the solution is not going to be helpful. It's just going to be data, right? You have to know which direction you go for. And I'll give you an example. This is a real example that I had to work, because I used to work with predicting stock market based off of what a portfolio manager want to do with it. So if the problem and they want to ask you, okay, predict which stock will crash, that's different than if you say predict which stock will double. Why? Because if the solution or what they're looking for is, okay, well, what will crash, I'm looking for different signals or different parts of the data that will help me indicate that. So my metrics will be different. So if I'm looking for a crash predictions, I might be looking at, okay, the data I would need is like debt ratios. What is the news sentiments? Because how do people feel? Are they happy? Or are they sad with what's going on with the stock market right now? All that will affect if the stock market will crash at all, right? Now, if I'm saying, okay, will there be a growth prediction? Okay, well, now I'm looking at and this is a real life example. Like, let's say we're looking at a SaaS company, and part of the growth prediction is that they have a new product coming out, and how many users, so user acquisition numbers, how many new users are being added like monthly or weekly. So like, okay, we could basically extrapolate from that using a certain model to say, okay, by this amount of time, you could have this amount of users, which is a substantial amount. So we could predict that this will actually double by this certain amount of time, so their stock will double. So my metric and what I'm looking for in the data is different than for if the stock will double versus if the stock will crash. I'm looking at a different metrics over here. So this is why it's very important, because we want to know basically when you have a problem here, the stakeholders want to know who's involved and why do they care? Like, what's the business goal? Like, what's the purpose of this, right? And what are the constraints, right? Like so usually I have like SMART goals, something specific that's measurable, it's time bound, right? And all these things, these goals are usually defined people who are not technical, because to tell you the truth, behind this is that you're being hired as an AI engineer to basically solve a problem, and by people who don't understand it most of the time. A large majority of the time, they're non-technical people, and right now people think AI is magic, right? So it's very important to define and design a problem and define it beforehand, and what the solution will look like, And again, the metrics, how do we measure, also known as KPIs, like key performance indicators? Because how do you know if you're on track or if you hit your goal? So you have to, in this case, we say, okay, well, let's say we say, okay, they say we want to see if predict which stock will crash, and we agree upon, okay, based off the data we have information like debt ratios and news sentiments. We would look at that. So that will be our metric for it. And we'll look at during our roadmap, our milestones, are we on track with what we predict these numbers will be to get the outcome we want. You have to define your metrics with that, because if you define a different problem and you want a different solution, again, like in this case, predict which stock will double. Okay, in that case, we're looking for growth prediction. So the metric in this case will be the user acquisition number. So we wouldn't care what the debt ratios or news sentiment are in this case. So that's why it's very important to get a clear understanding from the stakeholders. What's the business goal? What is the solution you're looking for? And what's the definition of done? And what's the key metrics? How are we going to measure it so we know we're on track? So we basically something doesn't get measured, it doesn't get improved, right? And here's the thing about it. I know in the social media and everything out here makes it sound like AI engineers all glitz and glamour right now. The harsh reality of it, that 80% of it is really just like cleaning messy data, getting it, going back and forth, waiting for approval. Okay, well, I found a paper that this could possibly work, but we haven't seen on this type of data set. But we have to retrain it ourselves because we can't use the data, or we have our own sensitive data. What's the cost of doing that? How long that costs? Versus, oh, well, I found a solution where there's a model that's already trained, it's already fast, it could work. But now the concern is, well, what's the cost of it? Do we have to put it in the cloud? Do we have access to it? Do we have to get approval by the different departments? The legal has to go through it. There's a lot of red tape, and you have to wait for months. So that's actually a lot of the job. But yet the deadlines don't change. So you still have to manage that. And then once you have it work, and then once you have that, you have to actually get it to work, right? Because if it's not working, then it's useless, right? So this is not a science experiment. It's not like a research part. You actually expect results. So that's where the other stress is, because you have to wait for certain things to get aligned, and then you can actually start to see if it works. And that takes a long time, because you're out there, you try something, why doesn't it work? Try to figure out what it is, tweak it, put it out there again. And the whole time you have to explain to the stakeholders when they check in because they expect, here's the input, here's some money to get it done. You said you're going to get it done by this deadline. You do your magic, and they come back at anything less than magic, they don't really care about, right? So it has to work. And basically you're going through the process, and that can be stressful, where you have to train it, test it. And then once it's working, if it's not working, go back to train it, go back to test it. And when it does, then that's another part is, okay, now you have a version that is trained and is working, at least in theory, with our training data. Now we have to ship it and put it in the wild, or put it in actual production, and then document how it is, and then monitor it and see how that works. That's a whole other beast right there. So what's the AI team size? What does it look like? Well, it depends. You could be solo, you could work with large squads, and I've worked in both. Actually, a lot of times when I'm brought on a project at first, especially since it's newer, that people want to use AI, they don't know where to start. So they get someone they know that done this before. So they bring me on to assess, been there for a few months, and then they build up a team. And usually during that few months, I assess the business, figure out what the needs are, and then give a prototype of how it would work. Once it gets approved, then I build out a team to actually scale this up, right? Now, the thing is about that is when you're solo, and let me tell you the reality of this, you're isolated, you have literally no support, because people generally, literally, when you speak to anyone else, they have no idea how AI works, what it's supposed to do. So they're like, you're here, figure it out, right? So you have to make it work. And at the same time, they're expecting magic out of you, right? But once you have that demo and they feel assured that, okay, this is going somewhere, this works, then you could, depending on what it is, like at least a lot of the times I was asked to build up the team, and then I led that afterwards. And I've done this at Fortune 500 companies, and you could see, even if you go on my LinkedIn and check out the past projects I've worked on for that building those out, like building the team setup, that's a process. And there's a lot of different parts where you want to, like I mentioned before, there's a lot of different roles in AI, you need someone who manages the data, like the data scientist. And then actually, if you're going to be doing this deploy, a lot of times you need a front end and back end or full stack, if whether you're doing SaaS or not, even if it's a local model or whatever that concept is, that you need somewhere that's actually processing the data and somehow it's being interfaced in whatever method that's being done. And then you need to model the data based on, meaning how do you take that, interpret the data, and make predictions off of that. And then after that, not only that, once you have it to work, there's a version that's a research version, then there's like the actual deployed inference version where it's already trained, it's not learning anymore, and then you have to optimize it. The deployment version is different because now you have to optimize it in the sense that you have to make the model smaller. You might change the precision of it or put in another architecture. You can even, I haven't done it personally and myself, but I've worked along adjacent other teams that once they had to build, they actually had a physical version of their neural networks model built, because neural networks are basically nodes, and they actually had physical like tubes. And the reason why is because it's a lot more efficient once they had it dialed in. So there's a lot of different ways depending on the needs for it. And here's the thing, like the glamour versus the real life. So obviously social media, everything's perfect. Everyone's a hero in their own story on social media. There's nothing ever wrong on it, right? When you see about AI and like you see people coding on the beach making like 500K salary and whatnot, which is not necessarily lying, but I have to pretty much manage your expectations versus like the real downside of the job. There's a reason why they're getting paid that much, right? Because you are literally expected to do magic, because they're like, hey, we don't have a problem. Hey, we could use AI. Let's get an expert to go on here. Not knowing, they're like, hey, just throw numbers, bodies at it, or throw money at it, and like AI can solve everything, right? So it doesn't actually work that way. Like I mentioned, even getting the data, curating it, processing it, making sure it could work, and having a model and having a realistic result to expectation of it, and also a timeline and what can be done. That is managing expectations from that, because that's one big thing. So there's a lot of stress of that. And the other thing is on-call pressure, right? So yeah, you get paid a lot for it, but at the same time, they're expecting it to work. And a lot of times you have that issue where like you're fighting it to get the model to work, and you finally get it to work. It's great, but you did it in your own test environment, and now you deploy it in the real world. And the problem with that is now, like, again, you get constant interruptions with this, because in the real world, you have a lot of other constraints or things you haven't seen, or it's in use cases or edge cases you haven't seen at all. And as soon as something breaks and the whole thing's shut down, you have to put out fires, and you're the resident expert, so you have to be on call. Doesn't matter if you're on vacation or whatnot, you have to make sure this works, or else the sky is falling right now, right? So that's the downside, and that happens a lot, is because you're solving problems that haven't really been solved yet, right? So it's a lot of pressure while you're doing it. Once you succeed, it feels great. Obviously, that's the glamour part people show in the social media part, but like getting to that part is a lot of work, right? So knowing that, and the thing is, a lot of people, you have to be able to understand the pressure that comes along with such a job. So why would you choose AI engineering if there is so much pressure, right? Well, like anything, you have leverage and freedom. If you actually are able to succeed with this, right, you're everybody's hero. You could do no wrong. It's actually said, I find it because I actually worked on this movie, because I worked in visual effects and Hollywood for years prior to going specializing in AI, and I worked on the Hunger Games movie. And if you recall, in there was a conversation with Prim and Katniss character, and Katniss wanted something. I can't recall what it was at the moment, but Katniss asked, well, aren't you important? And she said, yes. And yeah, important people get what they want. And that's basically leverage. If you have an important skill that's super valuable to a company, they would bend a lot of rules for you, right? You have a lot of freedom. You can come in when you want. You can leave when you want. You could, as long as you deliver. That's the whole thing. That's where you get the high compensations, right? You get paid for that, and as long as you deliver on that. And this is one thing I have to mention regarding the compensation for that, right? So this like the low end, even a junior coming in is like a 200K job. And honestly, I still think that's pretty low. I haven't seen anyone personally anyone who started with that. It's at least 300K for at least the people I know. And I'm not like everywhere is different, obviously, and there's different things about that. But compared to most jobs, especially the need for this now and how everybody wants to get this, 200K is pretty much like the low end that you're expecting. Now, this is why it's super important to actually prepare for your coding interview, because the coding interview, one, is just testing in general. Okay, do you have the basis skill set to work here? And yes, everyone complaining is that nobody actually works in this. It's kind of like studying for the SATs. Like nobody actually does this in real life, but it's a standardized way of testing people. And the thing is, you have to train for it, just like you would have to study for like the SATs. Even the most senior engineers who worked for years and like PhDs and master of their domain, they still have to study for the coding interview. Because the reason why is because these major companies actually have different ranking systems of a certain position. And especially the major fan companies, they have different names for it, but they have the equivalents for that. But basically your coding interview, how well you rank, you could have your salary go from 200K all the way to like $1 million. And I know people in these ranges of that, right? So you actually want to study and make sure you put your best foot forward, and people study for this hardcore for at least 6 to 8 weeks before they feel prepared, like actually focus on this, because there's a huge compensation difference. And the other thing about it is just like there's a famous example of the developer of Homebrew. If you guys know Homebrew, if you ever work on a Mac and you ever install any applications on your Mac, the package manager, one of them is called Homebrew. Most likely, if you ever did it through command line, you probably use Homebrew. The developer for that, did a code interview and didn't do well and didn't get in. I believe it was Google. And then it was a famous like tweet he put out there saying like, yeah, the company uses like 90% of the company uses my code, but I can't get in there. And the main thing is like he bombed his from my understanding, he bombed his coding interview. So obviously he's a skilled coder. I mean, it's a known application. Even the major company that he was trying to get into uses it, right? But just telling you, if you're going to do your coding interview, super, super important because this is definitely quality of life changing salary range of this, right? So take it seriously. Should you choose AI engineering or should you get into it? To be honest, anyone can learn the tech. Yes, you can learn the tech to become an AI engineer. The technical skills, I could tell you what you basically need to do. Learn Python. What I recommend, first month, learn Python. Why Python? Mainly because it's kind of like the de facto language right now to use AI engineering or machine learning engineering. PyTorch is kind of like the dominant framework that's being used, and papers are using it. Yes, you could actually use machine learning or build any framework from any language, but this is kind of the de facto. So if you want to just jump in and work with industry standard, learn Python. Learn the math that you need to understand what's going on. So math, calculus, mainly specifically like gradients, which is like derivatives. So calculus 1, 2, gradients will be like 3. Calculus 3, like a multi-dimensional, multi-variable calculus. That's level like calculus 3 of that, right? Also matrix mathematics or linear algebra for that, and statistics, like learning classical statistical models. Linear regression, that's another one, right? And then the libraries, libraries or the machine learning libraries. So if we're talking about Python here, well, the libraries that matter for the data science stack library. So if you install, let's say, Anaconda, which is a package manager for Python, or actually package manager in general, but it specifically have curated modules for Python that already have the versions curated, so they all work together, so you don't have to install it for all the data stack that you could use for data science and like machine learning that you could build on top of it. So mainly part of that, you want to know NumPy, which is numerical Python, which is to do the math and linear algebra and quick math with large data in Python. Then you want to use pandas, so think of like as if you're using Excel sheets but in code. And then you also want to visualize that, because when you take the data and interpret it, you want to show visualization to stakeholders who are not like executives who want to solve a business problem but they don't understand the technical. So you have to show pretty graphs to show they understand that, to show they understand how to interpret that. So that's why you want to use something like Matplotlib or Seaborn to visualize your data, or to use dashboards to make it look good, right? So yeah, so you could look these up right now. You can learn it, go to wherever there is to learn Python, do like one of those 100 days of coding challenges or something like that. You could look up NumPy, how it works with the pandas or the libraries and all those things, right? Now, the thing is about that, like anyone can learn that. That's on YouTube. What's overlooked and what's actually needed for the job are the soft skills. So what is that entails? Like I mentioned before, you see the glitz and the glamour of what an AI engineer and the money that you could get, or possibly, I don't want to say like everybody gets that, right? Like it's hard work. There's a trade-off of why you get that, right? So I don't want to make it sound like it's easy money, like you actually have to work for it, right? But why there's a frustration tolerance, because you're coming in and executives are expecting for you to do magic. So you have to be able to understand or also put up with when something's not working and you're hearing the grumblings of like, oh, we tried this model and it broke everything. Does he know what he's doing? And things like that, right? Or communication gaps where you'll see, especially when you're talking to people who ask you to do this, like, solve a business need. They expect you to do magic with it. They don't know exactly what they want. They just know that they want something great and AI will solve it. So they can't clearly articulate what's needed. So you might go through a few iterations showing something and it's not what they expect. And they're like, okay, we don't get this. Or they might start having doubts. You have to be able to extract the information you need and learn from it, so you can actually hone in on exactly what they're looking for and interpret that down back to the data science of it, to the AI engineering part, so you can actually map that out to work with the input they have, the data they have, process it and interpret it in an information in a way that they understand. And again, the other problem is when it's going to happen where all the red tape that you have to deal with, you have to get the approval of it. Things will move a lot slower, yet your deadlines don't change. So they're like, why isn't this happening? We're like, well, I'm waiting for the approval from you guys. So a lot of times they're not going to be understanding. So you have to deal with that. And then when you do get it, you still have to figure out how to make it work. And I guarantee you the first couple of times how you thought it's going to work is not. And then you start panicking because, okay, well, I'm missing my deadlines. I have to show a presentation. I don't have anything to show for it. And nobody's going to take excuses. So these are the things that you don't learn from watching YouTube videos, right? And then at the end, once you do have it to work, you have to be able to communicate them, right? And yeah, most of it is errors. Things don't work out. Things don't line up. The versions don't work out. You don't have the data. You don't have access to it. The legal didn't approve certain things, so you have to make your own models and all that. And you just rinse and repeat. The other thing is training takes a while. So you build it and you have to sit down there and wait. And then it after like 20 minutes of the first build, it fails. You have to figure out why, because you get some cryptic error. You have to go back and try it again. And then you do it. And then you could spend like 2 days just to get it to start training or start working, because of you're using different model architectures, you're using different computer. It's in the past, you used to have certain levels of precision of Python. And now the new version uses PyTorch, and now you have to make them a certain way and you have to cast this or whatever. And then the data you have to clean up, and then now you get new data that comes in that's a different format. So you have to rechange your cleanup scripts and all that things, right? But the thing is, what drives a promotion and all that is that through all that, which is the reality of it, if you make it through and you stay resilient and disciplined and actually succeed with it, you are a superstar. You're a hero for it, right? And at the end of the day, like, people congratulate you and it's great. And that's what it is. Basically, the final decision, it doesn't matter what happens all before, is as long as you get the W at the end, Then you have the leverage and the income. Now you have that leverage to command that income and basically have that work-life balance, which is actually more work-leverage balance. I think that's a more accurate statement, because the more valuable you are to the company, and you could actually deliver magic for what they ask, the more you benefit from these two things.